Blockchain 101 – Understanding the Basics. Blockchain technology is one of the most revolutionary innovations of our time, providing a robust foundation for a new era of digital trust and decentralized operations. At its core, blockchain is a distributed ledger that records transactions in a way that is secure, transparent, and resistant to modification. It achieves this by grouping information into blocks that are cryptographically linked to one another, forming a chain that begins with an initial block known as the genesis block. Every block contains a list of transactions along with a unique identifier generated by processing the block's data and the hash of the preceding block through a mathematical algorithm. This linkage means that altering any piece of information in one block would require recalculating every subsequent block's hash, a computationally expensive and practically impossible task without control over the entire network. The concept first gained widespread attention when it was used as the fundamental technology underpinning Bitcoin, the pioneering cryptocurrency introduced in a 2008 white paper by an individual or group under the pseudonym Satoshi Nakamoto. Bitcoin demonstrated that it was possible to create a system where transactions could be verified in a decentralized manner without relying on a central authority. In doing so, it solved the double spending problem and challenged the convention that trust in financial transactions must come from large, centralized institutions. Instead, blockchain technology leverages cryptographic techniques and consensus algorithms to create a trustworthy system where every participant acts as both a user and a verifier. This breakthrough has laid the groundwork for a host of applications beyond digital currencies, with blockchain now seen as a transformative force across many industries. A critical component of blockchain is its decentralized nature. Unlike traditional databases managed by central entities, blockchain data is distributed among a network of nodes, computers that maintain copies of the entire ledger. Each node participates in validating new transactions through consensus mechanisms, such as proof of work, POW, or proof of stake, POS. In POW systems, for example, nodes known as miners compete to solve complex mathematical puzzles, and the first to succeed earns the right to add a new block to the blockchain, receiving a reward as an incentive. This process not only secures the network against fraudulent transactions, but also ensures that no single entity can gain control over the entire ledger. In contrast, POS assigns validation power based on the number of tokens a participant holds, which helps reduce the energy consumption associated with mining while still maintaining a secure system. By distributing power among many independent nodes, blockchain creates a decentralized structure where decision-making and trust are shared collectively. Security and data integrity in blockchain are maintained through advanced cryptographic methods. Public key cryptography plays an essential role in safeguarding transactions and user identities in the system. Each participant in a blockchain network possesses a pair of keys, a public key that acts as an address visible to everyone on the network and a private key which is kept secret and used to sign transactions. This approach ensures that only the rightful owner of a digital asset can authorize a transfer, and it prevents anyone from impersonating another user. Furthermore, cryptographic hash functions are used to generate the unique identifiers for each block, binding the content of the block to its hash and to the hash of the previous block. This method of chaining blocks together means that any attempt to alter the content of a block would be immediately evident because the change in data would result in a different hash, breaking the chain's continuity and alerting the network to the tampering. While blockchain technology underpins public cryptocurrencies like Bitcoin and Ethereum, its versatility extends to many other areas, and not all blockchains are designed the same way. Public blockchains are completely open, allowing anyone to join the network and participate in the validation of transactions. These systems are highly transparent, as every transaction recorded is visible to all participants. Conversely, private blockchains operate on a permissioned basis, where only authorized entities can read, write, or validate transactions. This model is often used by organizations that require enhanced privacy and control over their data, such as financial institutions, healthcare providers, or supply chain managers. There are also consortium or hybrid blockchains, which combine aspects of both public and private systems to create a tailored environment that offers a balance between decentralized trust and controlled access. One of blockchain's most compelling attributes is its immutability. Once data is written into a block and verified by the network's consensus process, it becomes a permanent part of the blockchain record. This permanence prevents retroactive manipulation of historical transactions and ensures that the ledger remains a reliable source of truth. The trust that users place in blockchain comes not from the actions of any central authority, but from the robust, mathematically proven design of the system itself. This level of security and reliability has attracted interest from industries where data integrity is paramount, such as in financial record-keeping, property registries, and identity management. Blockchain's inherent capabilities have given rise to innovations like smart contracts, self-executing agreements with the terms directly written into code. Running on blockchain platforms such as Ethereum, smart contracts can autonomously execute actions when predetermined conditions are met, eliminating the need for intermediaries to enforce contractual agreements. This automation streamlines complex processes, reduces the risk of human error, and cuts transaction costs, making smart contracts attractive for applications ranging from supply chain logistics to legal agreements and even voting systems. With smart contracts, trust and enforcement are built into the technology, ensuring that agreements are executed exactly as intended without central oversight. The potential of blockchain, however, is not without its challenges. One of the most commonly cited limitations is scalability. As transaction volumes increase on a blockchain, the network may experience congestion, leading to slower processing times and higher transaction fees. For instance, during periods of high demand, networks like Bitcoin and Ethereum have faced significant delays and cost increases, prompting researchers and developers to explore various scaling solutions. Techniques such as Layer 2 protocols, where secondary channels offload the bulk of transactions from the main chain, and sharding, which divides the blockchain into smaller pieces that can be processed in parallel, are being developed to address these issues. Additionally, the environmental impact of energy-intensive consensus mechanisms, particularly POW, has led to growing concerns about the sustainability of blockchain networks. These challenges are actively driving innovation, as the community works to balance the need for decentralization and security with efficient performance. Beyond financial applications, the impact of blockchain is being felt across a wide variety of sectors. In the realm of supply chain management, blockchain's ability to provide an immutable record of every transaction and movement of goods helps companies track the provenance of products, ensure quality control, and reduce fraud. In healthcare, secure sharing of medical records and patient data via blockchain can improve patient care by providing a comprehensive, tamper-proof history of treatments and diagnoses, while also enhancing patient privacy. The creative industries, too, are finding new opportunities through blockchain, where digital rights and the monetization of creative works can be managed efficiently via non-fungible tokens, NFTs, and decentralized platforms. The versatility of blockchain has sparked interest from governments and organizations worldwide, each exploring innovative ways to harness its potential to create secure, transparent, and efficient systems for managing data and value. Another dimension of blockchain's impact lies in its ability to transform traditional economic structures by removing intermediaries and reducing transaction costs. In conventional financial systems, multiple layers of intermediaries, such as banks, payment processors, and clearinghouses, are involved in verifying and processing transactions. Blockchain disrupts this model by enabling peer-to-peer transactions that are directly recorded on the ledger. This not only streamlines operations and minimizes costs, but also opens up financial services to populations that have historically been excluded from the banking system. By providing unbanked and underbanked individuals with secure access to decentralized financial networks, blockchain has the potential to democratize financial services and promote greater economic inclusion on a global scale. Data management and cybersecurity are also being reimagined through blockchain technology. The decentralized architecture means that there is no single point of failure vulnerable to hacking or data breaches. Instead, data is replicated across a network of nodes, enhancing security and ensuring continuous availability even if one or more nodes go offline. The robust cryptographic techniques that protect the ledger also help safeguard sensitive information from unauthorized access, making blockchain a promising solution for securely storing and sharing digital records. This increased security and transparency can help build trust, not only in commercial transactions but also in the management of government records, academic credentials, and even voting systems, where integrity is crucial. Interoperability between different blockchain networks represents one of the next frontiers for research and development. As more specialized blockchains emerge to serve particular applications, be it finance, healthcare, or supply chain management, the ability for these networks to communicate and exchange data seamlessly becomes increasingly important. Efforts to create standards and protocols that allow disparate blockchains to interoperate smoothly are gaining traction, and innovative solutions such as blockchain bridges and cross-chain protocols are emerging. These advances promise to unify the growing ecosystem of blockchain technologies, allowing for more versatile and integrated applications that can leverage the unique strengths of different networks. Understanding blockchain may seem daunting initially due to its technical underpinnings and the novel concepts it introduces. However, as one becomes familiar with its core principles, decentralization, cryptographic security, consensus, and immutability, it becomes clear that these features form the building blocks of a system designed to empower users and distribute trust among all participants. The community of developers and visionaries pushing the boundaries of blockchain is constantly refining these technologies, ensuring that the systems remain robust, scalable, and adaptable to the needs of a rapidly evolving digital landscape. Such ongoing innovation is critical, given that the potential applications of blockchain extend far beyond what was originally envisioned in its early days. Blockchain technology not only challenges the traditional paradigms of centralized control, but also redefines how we conceive trust in a digital era. By embedding trust in mathematical algorithms and decentralized consensus, blockchain creates an environment where every transaction is independently verified and securely recorded. This has profound implications for a wide range of activities, from financial transactions and legal contracts to supply chain management and digital identity verification. The transparency inherent in blockchain ensures that data is accessible for audits and analyses, further reinforcing the reliability of the system. As society increasingly moves towards digital solutions, the role of blockchain in establishing a secure and transparent foundation will only become more significant. Ultimately, blockchain technology has ushered in a new era wherein trust is not merely assumed or enforced by centralized institutions, but is rather embedded in the technology that underpins our digital interactions. As more people begin to understand the significance of distributed ledger technology in providing secure and reliable platforms for conducting transactions, protecting intellectual property, and managing data, we find ourselves on the precipice of a revolutionary shift in numerous aspects of society. With proper governance, collaboration among stakeholders, and continual technological advancement, blockchain holds the promise of constructing a future where transparency and efficiency are the norm rather than the exception. Whether it is by transforming financial services, streamlining supply chain operations, or enabling new forms of social and economic participation, blockchain technology is increasingly proving to be a formidable force in reshaping how we perceive and interact with the digital world. In this era of rapid technological change, embracing blockchain means embracing a future where every transaction, every interaction, and every datum is securely recorded, inherently trustworthy, and accessible to all who need it. The foundational principles of blockchain, decentralization, cryptographic security, consensus-based validation, and immutability, are not merely technological innovations. They represent a profound rethinking of traditional paradigms around authority, trust, and value exchange. As we stand on the threshold of this transformative journey, it is clear that understanding the basics of blockchain is essential not only for technologists and entrepreneurs, but for anyone interested in making sense of the new digital frontier. Reflecting on the evolution of blockchain over the past decade, it is evident that the technology has moved from a niche digital experiment to a cornerstone of modern technological infrastructure. With its potential to resolve issues of centralized control, inefficiencies, and data vulnerabilities, blockchain is set to redefine both the economic and social fabric of our interconnected world. The debate surrounding its scalability, governance, and environmental impact continue to stimulate innovative approaches and foster a dynamic landscape of research and development. As blockchain integrates further into everyday systems, its influence will extend beyond the realm of finance, becoming an integral part of our digital identity, legal framework, and even civic participation. The coming years will undoubtedly see more practical implementations, regulatory clarifications, and global collaborations aimed at unlocking the full potential of this groundbreaking technology. In embracing blockchain, society as a whole stands to benefit from a more resilient, secure, and transparent digital ecosystem, fostering an environment where innovation thrives and trust is built into the very core of every digital interaction. In summary, blockchain technology represents a foundational shift in how we manage data, conduct transactions, and create trust in the digital age. Its decentralized structure, secured by advanced cryptography and governed by rigorous consensus protocols, creates an immutable and transparent ledger that underpins a diverse range of applications. From revolutionizing financial services to enhancing supply chain transparency and enabling secure management of personal identities, blockchain is poised to reshape many aspects of our lives. As we continue to navigate the challenges of scalability, energy consumption, and interoperability, the ongoing innovation within the blockchain ecosystem will determine how rapidly these systems become integrated into mainstream use. With each new block that is added to the chain, the promise of a more open, secure, and equitable digital future draws closer to realization.